Okay.
Meaning if there's 200,000 kids, they'll have 200,000 student devices. Hopefully, ASR devices.
George Carey, how are you?
Good afternoon, Robert. How are you, sir?
I'm good.
Excellent. So we got some stuff down at Choate.
Yeah, you saw those 2 invites?
Yes, thank you.
Yeah.
Hey, Michael.
Hello.
How are you?
What are you?
Good.
Oh, I'm in the wrong meeting. I got 2 different meetings I'm supposed to be going to.
Yeah, you're supposed to be in the, you going to the O2 sensor meeting?
Yeah, I'm going to sensor.
Okay.
Wrong one. All right. Bye, guys.
See ya. All right, guys. So 2 o'clock, we'll go ahead and get started. So we're going to go over the Lochinvar Smart Control. So majority of this class is really specific to any of the boilers that have our smart control. That's going to be the condensing products. We're going to cover basically going back to 2010 up through the current version today. This is residential, commercial, armors. But what's important to know is the control platform that we're using today in 2020 is the same control platform we used in 2005. So what you'll see in the menus and in the background is the same then as it is now. We've added some features. We've made the display a little larger and that sort of stuff, but all of Lochinvar follows along that same sort of thing in those general principles. Even up into the crest, the sink boiler, all of them follow that same thing. You'll see 2 different controls as we use there. Basically the first, we call it, I guess, the 2nd generation smart control, and now the new 3rd generation smart control. I'm going to toggle back and forth a little bit between the 2 of those and just show you how those work. Now, for the most part, I do leave it muted, you know, in case dogs barking in the background, wives, husbands coming in, whatever, phones ringing, that sort of stuff. There's a chat screen. If you don't see it up on the right-hand side now, down either at the bottom or the top of your screen, you should be able to pull down a chat and send that over, and we'll kind of try to answer those questions. And then we're going to kind of jump back and forth. I'll come back and see that, you know, everything's going well and if you have anything to do. So right now, leave you guys all on mute. I'm going to load up the PowerPoint. We're going to share screen and off we're going to go, and we're going to have a great time, I'm sure. And there we go. All right, so basically we're looking at Lochinvar's smart controls, what we're talking about. Now I'm Rob Ellis with FIA, so we are the manufacturer's rep for Lochinvar here in New England. So let's kind of jump right into it. The smart system control that we're going to talk about this is the newest version of what it's going to look like right here. We have the 3 colors of the screen. The blue screen, that's its normal operating mode. The yellow screen, kind of being that maintenance reminder. And then the red screen, that's our lockout screen. And I want to take just a second because people sometimes miss this. We look at our lockout screen, you see a lockout 1, and we'll talk about space heat demands in a little bit because there are 3. But that lets you know that you have a space heat demand, the boiler's locked out, but go down here. that'll tell you what the lockout actually is. Okay, so it'll always be printed up on the screen and when it happened, the date and time. So basically setting the date and time in the boiler does become important so you can see that information. Maintenance required, that's like to change oil light in your car. It merely goes off on a certain number of months or ignitions or hours of runtime. If you have programmed your name and number into it, that's going to come up there. If you don't like the customer, you don't want to go back there, don't program your name and number into it. Okay. Low voltage connection board. I put this up here just so you guys can see it. When we talk about those varying heat demands, that's going to be right here, these 3 heat loop demands. Okay. We'll talk about those a little later, but and it'll correspond with 1, 2, and 3. All right. Lock and link is an easy way to upload the parameters to the boiler using a thumb drive is what we're able to do, and it plugs right into there. Now this feature is on the 3rd generation display. So this one with the big red overlay around it is the one that you can use that. Now a couple of cool things you could do with that. One is if you talk to your your distributor, your Lochinvar distributor, or your FIA salesman, you can get a pre-programmed thumb drive to use. If you want to program your boilers and then upload those parameters to a thumb drive to use on other ones, you can do that as well. It's kind of a slick little tool that's there. Okay, just plug it in and go. All right, this is actually the 2nd generation control with the blue screen in here, but we're going to use this one because this is a PowerPoint that we've been using for a while for interaction and navigation of what goes on. The main display is telling you what's happening in there. Standby means the boiler does not have a call for heat. So it's just sitting there waiting for something to do. Down in here, you're going to get, these are your sensors that you've added to it. Your system and outdoor are ones that you wire onto the control board. The outlet sensor is the one that's built right into it. Your scroll knob will move you through the various screens and will also work in changing the parameter that you're programming. And it corresponds with this guy right here. Okay, that center set point means push the scroll knob. Now, the one that gets a little confusing sometimes is the menu and shutdown button. We'll talk to people about, especially on the phone, hey, I need you to push the menu button. The menu button is this select key. Shutdown button is this select key. Why don't they say menu and shutdown here? Because they will change on varying screens. Sometimes this could be the exit or the home button or the save button. All right, reset button, my boiler's in lockout, I need to take it out of there. And that there is the service mode button. I don't know if I'm showing up on the side of your screen, but the paper clip is the tool to get into the, put the boiler into service mode right there. All right. Now this is the 3rd generation display, and instead of walking through the 2nd generation to show you these, I wanted to use this one today. So as I turn my scroll knob, I get the different displays, and this is just the view menu, if you will. So in this case, it's letting me know what my sensors are. Now, once I connect the sensor, it will automatically show up on this screen to see. Okay. My next one, as I scroll through, would be my delta T, my flue temperature, my flame signal, and my fan speed. Delta T will ask you that from time to time. Hey, my boiler's firing. It's got this going on. We might ask you what your delta T is. So just scroll through. It's going to do the math for you. Next one is letting you know the conditions of the safeties in those different switches in here. Letting you know that whether they're closed or open, or in this case, on or off, on being closed, off being open. Next one is your BMS screen. So if I'm connected to a TechMark control, that's going to show up right here. Down at the bottom, my boiler pump output. The 2nd and 3rd generation controls have the ability to control a variable speed pump, and they'll tell you right there what speed they're sending out to it. In the 3rd generation, you're going to get that variable speed pump comes right with the boiler. Oh, sorry there. This one here, runtime and cycles. Now, the thing about runtimes and cycles is important. This is a good telltale for the service contractor. Is my boiler short cycling? And I'm going to see that right here. We would look at it. In this case, I have 100 cycles. for 200 hours of runtime. So I'm getting 2 hours of run per cycle. That's outstanding. Generally, we don't want to see any more than 6 cycles per hour. And this is where we would ask you to go and take a look at that. And then the next screen gives you your last 10 faults here. Now, I just picked one random when I screenshot this here. So this was number 8, and it was flame failure ignition. It gives you the date and time. Every time you push the button here, it walks you through the last 10. Okay. And the final screen in the 3rd generation is this guy here. I particularly like this one for a lot of troubleshooting things because it tells you everything in one screen. It's my system temperature, what's my flue temperature, my inlet, my outlet, my tank temperature, my outdoor temperature. And then if the boiler is actually firing, right here in the middle, it's going to give you the firing rate of the boiler. So a lot of times if you're troubleshooting, you want to know what's going on, go to this screen first. If you're like, hey, my water temperature is not warm enough, and you're like, it's 30 degrees out, you look at this screen and it says it's 60 up here, you know you got a problem with where that outdoor sensor is reading. And the electrician might have done a really good job of getting it in a nice, sunny, warm spot. So definitely want to take a look at that. All right. So let's look at what screen's going to show us when the boiler itself is actually running. And again, this is the same on the 2nd and 3rd generation. It's going to look the same. Just the color of the screen is going to be a little different, the shape of it. So in this case, on the left-hand side here, I have a system heat call. Now, how do I know that? So I have the 1, 2, and 3. The 2 has a house lit up. Now what that's telling me is that I have a heat demand for all 3 temperatures, 1, 2, and 3. Temperature 2 is looking for the warmest water. That's why it gets the house over it. As we look down here in the system, so anytime I have parentheses like I do here, that's a target temperature. When I don't have parentheses, that's an actual temperature. So in this case, this boiler system is at 76 degrees. Its target is 140. The boiler outlet is 81 and outdoor is 26. We're firing at 100%. Move over here to the domestic hot water call, which we see here, the hot water symbol's lit up. Now in this case, my outlet temperature is targeting what's going on. So I got 82 degrees is my outlet. I'm targeting 180. This would be a scenario where my domestic hot water is probably piped directly off my boiler. So I'm no longer going to target the system because I'm not putting water onto the system. I'm coming right out of the boiler, and that's why it's going to switch over to outlet temperature targeting. All right. So again, just all the little guys there. If I want to save settings when I'm doing that, I hit exit when I'm all done making a change. After that, I'm going to hit home. I will get a message from the boiler. It's going to say parameters uploading. All right. I get into the program mode. It's going to be this left select button, which is the menu button. I'm going to press and hold that for 5 seconds. Now understand these are southern boilers. And if you look at 5 seconds in the South and 5 seconds in Boston, those are definitely different amounts of time. So basically press and hold the menu button till it asks you for the password. It's the safest way to do it. The password is 5309. That is Jenny's phone number. So 867-5309. That is that's the password. Okay. Once you get it in there, you hit the save button. You'll now be in the programming mode. So now we get into our menus. They said earlier, these menus are the same. If I went back to a boiler from 2005, and that was a little cumbersome to get in and program, but I had the same menus. We referred to them as A, B, C, D menus, but they relate right back to the same thing. So parameters from those are the same as parameters today. If we have extra parameters now, that's okay. The other one just didn't get it. We just added more to it. What's important though is I can connect a boiler from 2005 and a boiler from 2020 together, and they will run and communicate with each other. Just always make the new boiler the lead boiler. So as I scroll through to get to where I want to do, I'll push the scroll button down. Right here is going to kind of blink and flash, if you will. And now I'm in an adjustment mode for that. Adjust it, get all done, hit my save button, hit the home key, and my parameters have been uploaded. So let's, you know what's great about muting you guys? It sounds like everything's going great because nobody says anything. It sounds like everything's going awesome. But don't worry, we'll get to any questions you have. When I want to change parameters and I want to program them, I'm going to go into my general menu. I'm going to go into my programming mode with that 5309, and then I'm going to see all my different menus. You see the little cursor there? It's pointing. I move that by spinning the scroll knob. Okay. When I get it where I want to, I push in the scroll knob. It'll take me deeper into that menu. So the one thing in the general menu that you might want to, that you do want to do when you first start with, is you're going to put the time and date in. A lot of things work off that time and date. Maintenance reminder, if we use any of the night setback features, data logging. So it's always important to set the date and time. And no, the boiler does not know daylight savings time. So you will have to change it for daylight savings time. Once you get that set, a couple of things that you end up with. Well, first of all, the software version, you'll almost never need that. That's something we might use in a tech support fashion, by being to know exactly, if we made a change in software, this is where we would go and see which version of it you have. If you want to make it Celsius versus Fahrenheit, doesn't happen a lot here, but we do sell boilers outside of the United States. So some of those we got to use Celsius. Night setback. So night setback is a way to tell it to kind of change the water temperature all by itself. Space heating night setback, residentially, we don't see a lot of use for that. You might see some commercially. And this is how it works. It's going to deduct whatever you set for a number from the target. So in this example, if the target's 152, the offset is 30, my new target's 122. Just a way to make it change water temperatures automatically, like an unoccupied mode, if you will. You set trigger times, when you want it to start and when you want it to stop. So the day and the time of both. Program those all in there. The boiler's now going to do all that all by itself. One thing you might use residentially, I know I use it at my house, is domestic hot water night setback. So over the course of an evening, the tank sitting in a 55, 60 degree basement is going to drop in temperature, and it might fire 2 or 3 times over the course of an evening. You can tell it not to do that basically by lowering the domestic hot water target temperature. So I do that in my house. It's 9:30 to 4 in the morning. My domestic hot water lowers in temperature so it doesn't fire at night. What I like about that, though, is when it's time to come on in the morning, instead of having just a little bit of temperature to make up, I'm now putting a load on. It might be 15 degrees, it might be 20 degrees that it's going to come and it's going to load up. Puts a load on the boiler. So it's a kind of an efficiency tool, if you will. And again, same thing, set your trigger times, your start and stops, and off you go. Your display timeout, how long you want that to stay lit up after you touch it. In this case, it's showing 3 minutes. All right, let's jump into temperature settings. Temperature settings, we have a few things here. One is minimum and maximum set point. What are those there for? That sets the big window. And a lot of times you can use this to prevent a homeowner from doing something. Let's say, for an example, I had a radiant system or I had a snow melt system. And I'll use the example, a dedicated snow melt boiler that might be going directly from the boiler out there, no heat exchanger, nothing, we're heating it right through. I might want to say in that scenario, that max space heat set point, maybe it's 140 degrees, because I never want to be able to put water hotter than that in here. And that's where I would set that here. And mainly it's going to keep somebody from making a change outside of the password protected area that would get them in trouble. So that's what that's really there for. Your offset and differential, that actually kind of controls where that boiler is going to operate and what its operating range is. That works kind of like this. So if I have a set point target of 170 degrees, now this number does change when you're using outdoor reset. So it could be 120, it could be 170, whatever it is. The boiler's operating range is going to be 10 above, 20 below. And that's what I've set that for. You can adjust that depending on your scenario for what you have. Maybe you want a little higher offset. Maybe you want a little tighter differential, whatever it is. But a 10-degree offset means 170 will run me to 180. If I get to 180, I'll shut off. If I cool off 20, I'll come back on. Now, a lot of times when I talk to people and we put in our setup guides, we tell you not to program your set point at 180. This is why. 180 here with 10 degrees above would get you 190. And the boiler doesn't like being at 190. It kind of messes up a little bit in that, basically that runway that we use to slow the boiler down and land. So 170 gets you 180. And that's how we generally will program that as the maximum. In the boiler logic, as I ramp up and I hit 170, I'm going to ease it down here. I'm going to back down to an idle. And as long as I stay between 170 and 180, I'll keep my boiler running. When I hit it, that's when I go into here. We want to try and keep the boiler just operating right here. We'll talk a little bit about ramp delay, and that's why we want to use the ramp delay. Okay? But here's all our set points, everything else. We have 3 opportunities to do it. Why? Well, because we can, so why not do it? But I can do baseboard, radiant, and hydro-air, and if I bring those 3 separate calls, the boiler's going to be able to differentiate what's calling and what it should do. So if you have a scenario where you're using radiant a lot, that's your main thing, and then every once in a while you got to pick up with hydro-air, you don't need the boiler to run at the hydro-air temperature all the time. It can run at the radiant temperature. When it needs to, it can bump up and go. Okay? Data logging, so I'm keeping track of, errors and that sort of stuff. And you just get into that screen. That's where you can reset any log errors. Good thing to do. After you've done an initial startup, it's a good thing to go reset the log errors, because we put a boiler in it first. We fired a couple of times. We didn't have, we didn't have the line purged. We got a couple of flame failure ignitions. We got some air. We have some main and reset high limits. We want to clear those out. So go into that reset log errors, hit the yes button, and you're going to clear those out. Okay. Functions. This is our service mode delay. So when I put it in service mode, how long will it stay there? So in this case here, this we're showing you is you'll get 10 minutes in service mode, or any of the safeties or limits. So it'll stop itself when it gets there. So freeze protection mode, the boiler does have freeze protection mode. If you turn the thermostat off and the house goes cold and that boiler senses 45 degrees, it's going to turn its pump on. Gets to 37, it'll turn its burner on. There's a 5-degree differential. Now this is actually adjustable. So if you're using that boiler in that snow melt application and it's all glycol, you want to shut that off or lower it down, that's fine. So that's adjustable there. Important to note, no power or no gas, no freeze protection mode. You do have to have both of those there to make those work. Okay. Let's jump into domestic hot water settings. This is one that is very infrequently used, and it should be used every single time. So domestic hot water settings, like here's an example here. 125 degrees, my tank temperature set point that I'm looking for, but my boiler temperature set point is 180. Generally, as a rule of thumb, 125, I don't need to go to 180. What I can end up with is some stacking of the water temperature. I can really run my boiler harder than I have to be. So in most applications, if you go 20 degrees above, so 125 up to 145, you're going to get enough domestic hot water. If you are undersized in your domestic hot water system, you potentially have multiple showers simultaneously versus showers back to back. Showers back to back, that 20 degree above is going to work for you. Multiple showers, you might need more recovery by running up to that 180 degrees if necessary. Your set point differential here at 6 degrees. So my tank at 125, if it cools off 6 degrees, so it gets to 119, boiler's going to fire, pump's going to turn on, and off it's going to go. My offset that you see here works the same as it did in my space heating offset. So I would go 10 degrees above. If you're nervous about lowering that 180 to like 145, lower it to 145 and maybe put a 20-degree offset in there. Now your boiler is actually going to go to 165, but it'll idle on the way. It'll keep it holding down there at that minimum firing rate. And that's what we want to do. We want that to run as long as possible. If you have domestic hot water normal right off the boiler, this is your switching time, okay? So that's your priority override, if you will. Again, here we talk about the minimum and maximum set points. This is to prevent the homeowner from turning his domestic hot water off or cranking it up too high. In the main control, without getting into password protection, because it is required by code, you can adjust the set point for the tank and those sort of things. This is here where you would give them a parameter of where you want them. You might say, hey, 120 to 140, no more. That's where I'm going to limit you. You set that, it's password protected, keeps them out of it. Next thing we see here is our domestic hot water type. So we have normal and zone. What does that mean? Normal is this. On a call for domestic hot water, I'm going to shut this boiler pump off and only run my indirect pump. That's it. That's normal. In zone, in this instance, it's a little hard to see. It's a little bit busy. My domestic, though, is piped up here as a zone. I'm going to run both pumps. So zone, I want to run the boiler pump and the domestic pump. Normal, I just want to run the domestic pump. Now, out of the box, these are all programmed for normal. So when you get it, if you haven't adjusted that, you plug everything in, you got it, you turn the power on, and your boiler goes to delta T high or manual reset high limit. Go in there and check and see how you have your domestic hot water programmed and see what it's doing.
Thanks. I want you to look at.
So domestic hot water max fan right here. So domestic hot water max fan. Now this is the scenario where your boiler is bigger than your indirect. And that's a scenario that happens a lot. And you can get into the fact that your boiler really starts to cycle. If I have a 200,000 BTU boiler and a 40-gallon indirect, I can really only take about 115,000 BTUs into my 40-gallon indirect. But I got 200,000 and there's nowhere to stuff them. So what's going to happen is my boiler is going to cycle because it's running so hard, nowhere to put the BTUs, cycle off, cycle on, cycle off, cycle on. So this is where we do that. We get to do a little bit of math to do it, just so you guys know it's not Common Core math. It's actually real normal math. So this scenario, I got a KBN 286. I got a 40-gallon indirect. My 40-gallon indirect will take 115,000 BTUs. My 286 gross output is 260,000 BTUs. I'm going to divide the 115 by the 260. Gives me 44%. Okay. The fan speed of a KBN 286 is 5,200 RPMs. Okay. I multiply that by my 44%. Gives me 2288. How do I get that so that I know what that maximum fan speed is? When you're in the programming menu in the domestic hot water and it says max fan, that number is your maximum fan speed. So you take that, do your math, and now you would program that in with 2,300 RPMs. Derates your boiler down on a domestic hot water call. And then it's going to show you your fan speed up there when it's running. All right. Let's talk about outdoor reset. So outdoor reset is a very underutilized feature. People are nervous about using it. They don't like to connect the outdoor sensors, stuff like that, but it's a pretty important feature. And one is obviously in the efficiency of the piece of equipment as far as fuel efficiency and for your customer, that sort of stuff. But another thing that's important is also I guess the way the equipment treats itself. You don't want it banging on and off because if our water temperatures are too hot, and I could heat the house with 120 degree water and I've got it set for 180 degree water. Remember the way that thing works. I'm going to run to 180 degrees, but at 120, probably somewhere around 130, my zone's going to satisfy and my boiler's going to shut off without modulating. So we want these boilers to be able to modulate. So use outdoor reset. How do I program it? Always the question, right? So I have a low and a high and a set point, low and high. In this example here at 25 degrees out, got 180 degree water, and at 70 degrees out, I have 70 degree water. And then at 70 degrees, I'm going to shut down the boiler and not let it fire. That looks like this. So outdoor reset curves are more of a linear line than anything else. So I would take my outdoor low in some real world settings, might be 10 degrees outside, 70 outside. I'm going to set my set point 170 at that 10 degrees outside. And I'm going to set 110 at 70 degrees outside. So 170 at 10 outside and 110 at 70 outside. And then this becomes my curve. So at 50 degrees, it's 130. At 30 degrees, it's 150. And when you get that customer that calls you and says, hey, you know, it's a little too cold at a temperature, don't just yank the outdoor sensor off. You got 4 adjustments, make some here. So if my customer were to call me up and say, you know, at 50 degrees outside, the boiler starts to, it's not as warm as I would like it to be. Probably come right down here, this setting here, this 10 and 170, and I could move this forward. So if I move this 10 to 20 degrees, that tilts this whole curve up, and it raises all those water temperatures up as we go, instead of just yanking the outdoor reset off. All right, and then it would shut down at 70 outside. You get to do the same thing 3 times because we have the 3 settings, 1, 2, and 3. One of the little features that you can use here, setback thermostats. So you take outdoor reset, you put a setback thermostat with it, and, you know, we've been telling people for years, hey, the best way to do this, turn your heat down at night, you know, energy efficiency, Energy Star thermostat, this whole thing. And now we want to say, hey, we want outdoor reset. We don't want you to set back at night. Well, here's getting the best of both worlds. Using a 2-stage thermostat, my first stage would have all my outdoor reset settings on it, and my second stage wouldn't. This one might be told go to 170 all the time. And in the morning when they get up, their thermostat comes out of setback, off that's going to go, and we'll go to the second stage and we will raise our water temperatures up, satisfy it, go back into outdoor reset. Kind of makes everybody happy, and we get the best of both worlds. There's our 2-stage thermostat, our zone relay, into our multiple heat demands. Oops. Again, you get to do it 3 different times for all 3 of the outdoor settings. Shift reset is just a feature that's in there. It's kind of a weird little feature. If I were to put 5 degrees in here on this shift reset, it would just adjust my entire outdoor reset curve by 5 degrees. Kind of a weird thing. This right here, boost temp, boost time, this is the cover your ass setting. So find that balance. I don't want my customer calling me to come back. I want them to be efficient. I want my boiler to run the way it should. Well, this is boost temp and boost time. You could be a little more aggressive with your outdoor reset, and then you could set boost temp and boost time and say, hey, if after 10 minutes, 20 minutes, you haven't satisfied, I want you to boost the temperature. So in this case, my boost time might be 20 minutes. My boost temp would be 10 degrees. So after the first 20 minutes, I've raised my target 10. After the next 20 minutes, I do another 10, and I'll keep doing that until I reach my maximum set point. So it's kind of a neat way to get the best of both worlds there. All right, 2 mountains, right? Looks like a camel moving down the road. So we talk about slowing the boiler down. So in normal operation, the boiler's sitting there in the basement and says, well, you bought a 200,000 BTU boiler. I assume every time you call me on, you need 200,000 BTUs. It doesn't know whether you have 1 zone or 8 zones. It doesn't know if you bought it because there's a party shower and you need 200,000 BTUs for a 120-gallon indirect, but you really need $50,000 BTUs, sorry, for space heating. So this is where we're kind of going to change this, because in this normal operation, I'm going to light, I'm going to go to 100%. I'm going to either satisfy the zone, or I'm going to satisfy the water temperature quickly, and I'm going to drop off. And then I'm going to do it again. So I'm cycling my boiler on and off. So we want to get into anti-cycling. This should always be enabled. And in any boiler you touch, it should always be checking this anti-cycling and make sure that that is set. All right. So you have the anti-cycling time and the anti-cycling differential. And this is just, if I've hit my target temperature, you'll see at the end of a call for heat, or it's satisfied, whatever it is, it won't allow the boiler to refire for 1 minute or until it drops 10 degrees in temperature. That's what this is right here, okay? But this is the one we want, ramp delay. We want to enable it. Once we do, we're going to get 6 steps. We can set a delay time for each step, as well as a percentage of the firing rate. So in this case, my first step is 2 minutes at 20%. In step 6, it's 1 minute, 100%. What does that look like? It looks like this. Now I have a call for heat. Instead of that race right up to 100, I'm going to hold here at 20%. Once I expire that time, I'm going to ramp up to whatever the next stage is. So 35%, and then it's 45%, and then it's 60%. So depending on what your application is, you could customize these all over the place. If nothing else, just enable it and allow the factory defaults in. But if I had a lot of zones and I've got radiant, I might extend these out, keep them lower. If I have hydro air, maybe my first step is a little bit higher, you know, just because I don't want cool air. So look at the different ways. The more zones you have, the more aggressive you want to be. If you're asking us, how long should my boiler run every time? We like to see no more than 6 cycles an hour. So that's 10 minutes. Set stage 1 and 2 for 5 minutes apiece. It's going to give you your 10 minutes of runtime, and then let the boiler go. But it'll hold it back. So we get into the control modes here. We can control with different sensors, the outlet or system sensor. Generally, when you connect the system sensor, it's going to automatically take over, and that's going to be what is controlling it. If you are using a BMS, you would turn it on here, BMS T-stat. That means that I'm going to get an enable on my boiler, and I'm going to get a signal, a 0 to 10 volt signal. So we would see this using a Tecmar switching relay, and I think George got a class coming up on those a little bit later on in the week. I could also be getting a 0 to 10 volt signal from like a Tecmar outdoor reset control, a TN2 system, a TN4 system, any of those. Because we use the same control across our platform, that's why you see Modbus here. Modbus is really kind of our commercial building management system control platform. And that's where we would activate or deactivate it here. Modbus timeout, that's just in the communication between Modbus or BACnet and the system. Let's jump into a Cascade address. So Cascade is us being able to control multiple boilers. All of our boilers have the ability to control 8 boilers. So and any of them can do it out of the box. So when you get the first, you take the one that you're going to make the leader and you set this to 0, it'll automatically become the leader and it'll communicate with the rest of them. All you have to do. The next thing you have to decide is, what's your Cascade type? And that gets into how we stage. So in this case, it's lead lag is my Cascade type, and I'm going to stage through, and I'm generally going to run